Okay, so for problem 5, part A will be covered on exam number 2, and part D will be covered on exam number 2. So what I'm going to talk about is part B and part C. Alright, so when you look at part B, what you should initially be looking at here is that you have probably one of the best nucleophiles that we've talked about. Right. And so I think the first step to remember in a reaction like this is identifying your nucleophile and then subsequently your electrophile. So in this case, there's two possible electrophilic sites, right? Is that we could either have an SN2 attack at this position, or we could have attack of the carbonyl carbon, right? And so again, this is the purpose of this question is that I give you the starting materials, I give you the products, and I want you to rationalize the flow of electrons to form these products. So let's look at the pathway that is incorrect. So if you get nucleophilic attack at the bromide, then the product that you would get out of that is this. And then hopefully you can reason through understanding that there is really almost no way to go from that to the product that we want. However, if you consider nucleophilic attack at the carbonyl carbon by cyanide, then what you get out of that is actually highly productive. And you can very easily draw that reaction pathway. Plus you get the enantiomer of this, so it's drawn like that. It's racemic, but you get the enantiomer of that. Okay, so the second one we're going to talk about is this reaction right here. How do you go from this to this? Well, I think that if you're confused by this one, the most important thing to do is to look in your textbook at the section on the E1CB reaction. So if we are going to treat this with a base, there are two positions of this molecule that can potentially be deprotonated. One is to remove this hydrogen, then the other is to remove one of these hydrogens. And actually, if you look pretty carefully, so having this hydroxyl group here will make the pKa of these hydrogens almost identical to the pKa of those hydrogens. If it was just a carbonyl, it'd probably be in the 20s. Putting the aryl groups on there will probably take it in the high teens, and then having that hydroxyl group for inductive withdrawal probably takes it down into the low teens, which is exactly where the pKa of that would be. So let's draw the resultant products of removing either this hydrogen or these two hydrogens. From here, it's very difficult to rationalize how you would get to this product. But from here, from generating a formal negative charge there, it's actually pretty easy to rationalize how you would do this. And this is probably one of the best examples of an E1 CB reaction in action. So, and then the other two, A and D from question 5, we'll cover before exam number 1 or exam number 2.